Welcome to this second video about the object pool pattern. In this video I will be talking about how to create a game in JavaFX, and it's going to be cool. So let's get started with that. So I'm just going to open NetBeans here. Just going to close this stuff. And just going to create a new project. And I'm going to create a JavaFX application because I'll be creating a game. And I'll say object pool game example. Let's call it that. Oh, sorry, I forgot. JavaFX FXML application, and then we'll call it object pool game example, right? And I like to call this FXML file, I like to call it main. That's it. So now we have this game example. Let's open up the project and look inside of it. So in here we have different things. First off, what I want to do, I'm going to ready the FXML file for the game. So I'm opening up the FXML file and I'm removing the button. Off we go. I'm removing the label as well. And I want to set a new size for the game. So I go to layout and I set it to 960 times 539. And do you know why these numbers are so special? Actually, they're not. It's because on my computer's desktop here I actually have a background image, which is this nice space image that I have, and it's actually 960 times 539. So this is just why I'm using these numbers. So let's save that. Another thing I need to do for this example, I need to get a hold of this anchor pane here. So I need to name it. So I go to code and I name this main pane. And the reason for it to be main pane is because it just rhymes. So it's a nice name. Okay. So in order to do these changes, I go to my controller and I check out. I right click the FXML file, make controller, and then I see the anchor pane pops up and I have to remove the label and the handle button thing. Away we go, so it just looks like this. Nice. So now I have access to the main pane. So in this game we're going to be using something that is called an animation timer. An animation timer is kind of like a motor of the game. It uses 60 frames per second to update the game logic. So it's a real-time game that we're going to be creating. And it's going to give us some problems as well, but we'll solve them along the way. So first off, we need somewhere where we can actually draw something. We can draw the game. So let's create a canvas. If you're familiar with HTML5, this is much like the one in HTML5. It's important that you choose the JavaFX scene canvas and not Advanced Windowing Toolkit. And we want to set the width and height as well to 960 times 539, like that. That's it. So now I have a canvas, and a canvas is something I can draw on. If I run the program, nothing really happens because I haven't put the canvas in here yet. So in order to put the canvas inside of the anchor pane, I'll do that programmatically by saying main pane dot get children dot add canvas. So now my canvas should actually be added to the main pane. Still I can't see anything, but it is there now. So in order for me to actually show something, I need to get a hold of the rendering. I can use this 2D context rendering thing. So I'm going to use something called graphics context. GC equals new, oh sorry, I have to get that from the canvas. Canvas.getGraphicsContext2D. This will give me 2D graphics that I can play with. This is what I want. Nice, and I have to import that. So now that I have the graphics context, I can actually draw something. So I can say gc dot draw image, and I can put an image at a certain starting point, x and y starting point. So that is what I will do. Set it at 0, 0. So now I need to import an image into my drawing here. So I define the image by writing image img equals new image, and again, important to use JavaFX and not the old stuff. And I can just put in a URL here. Okay. And I just put the name of my image. I called my image bg.rbjpg, like this. Okay. So this should work, but it doesn't, because it cannot find the image, because right now it's on my desktop, so I get this weird load exception here. So what I'm going to do, I right click my project, I go to properties, and I can see my project folder. I copy that, go to Explorer, and I find my project here. I go to my source folder. Okay. So now what I want to do is I want to copy the background, and I also need this rock. I copy that in here. Boom, now it's there. If I now go back here, I can see it should be in here. Okay, so there it is, right? BG and rock. Let's try again. Wow, that is beautiful, right? Really nice background. Okay, so now it's working. So now I have my image background here. The next thing I need to do is that now I also want to have my stone in there. So I'm going to say image rock. Let's not call it stone, let's call it rock. New image, and then I put rock JPEG. Unfortunately, this image is not the best image. Let me show you. So if I draw this, you'll see it has a white background, and that's because it can't have transparency because it's a JPEG image. So that's why it is. So another thing that you saw is that the rock is really big. I actually want it a lot smaller. You can actually set that. You can't set that when you draw it, but you can set that when you import the image. So if you do like this, you can actually set the requested width and height. Then you have to set preserve ratio, which will tell it to preserve the ratio between the sides. And you can set if it should use a more inefficient, no, not inefficient, I don't know what the word for that. If it should use a better way of actually resizing it, which will give a nicer image but will be slower. That's what I wanted to say. So let's request a height for 25, and then say yes, we want it not to lose its aspect ratio, and also we want to use the expensive way of resizing. Let's go. So now it's a small rock. So a nice thing that we can notice now is that we can set the x and y value. So I can set this to 25. This will move it 25 pixels to the right. And I can also set this to something like 25, and it will move it downwards 25 pixels. So that's it. So now you probably can see that we have to have something going that will actually move this rock here. So the problem is, if I do something like a while loop for moving the rock, I would actually just end up hogging all the CPU power and the entire GUI, so everything would just hang and nothing would get updated. So that is why it's very neat that there's this built-in thing in JavaFX called animation timer. Animation timer, which is a really neat class. So we import that. Should be in the JavaFX animation library, and we'll just call this t equals new animation timer. We will automatically, this is animation timer, it just has one method called handle, and you will get the amount of nanoseconds since the beginning of time. Not like that beginning of time, but yeah, for the computer beginning of time. So this is equivalent to the system dot nano time. So returns the current value of the running Java virtual machine's high resolution time source in nanoseconds. So this is elapsed time, not since the beginning of times in that sense. Beginning of fun times in this game. Okay. So we can put anything in this. For example, I can write this hello. So this hello would run 60 times per second, because the animation timer is actually 60 frames per second. So it will update 60 times per second. Let's see that. Won't work now. So another thing it will do, it will spawn a new thread. So the GUI here will be running in a program by itself, and this will also run in a program by itself. So in order to start it, we actually have to say t.start, otherwise it won't start. So let's just remember to do that. So now we can see this is done 60 times per second. It's hard to see, of course. Would be more fun if we could move the rock, right? So let's just try to do that instead of writing hello. So let's say that now I want to move the rock. So I take this one draw image thing, put it in here, and then I need to move it some amount of time. So let me do something. Let me say long, and then say start equals system nanotime. So this is the time before I go into the animation timer, and then I can calculate something here. I can say long elapsed seconds equals now minus start. Okay, so this is really not seconds, this is nanoseconds. So I just have to divide by 1 billion. What a large and nice number, right? So I divide by 1 billion, and then I get the elapsed time in seconds. So if I actually do something like this, elapsed, and then I say elapsed seconds, we'll see that time will actually count upwards. So we see this is still running nicely, so this is running in its own program or its own thread, counting up each second. So it's drawing it 60 times per second, but we see it's counting every second. So let's just not do that then. So now it's working. So let's say that instead of the y value here of 25, Let's take the time in seconds, so that will mean that it will actually move 1 pixel every second, which is really slow, but let's see it anyway. See, now it's running. Let's speed that up. So let's say 5 pixels per second. Wow, right? It's really slow. So what's going on here? Why is it dragging like that? So it's creating this tail thing because the way that it works in JavaFX is that it actually just draws upon the last picture. So it means it just draws upon this canvas here, which already has a background and the other rock and the other rock and the other rock. So we have to kind of reset the picture every time. So how we can do that is we can just take this background, let's call this image background like this, and let's just put that up here so this will clear the screen. Clear screen like that, and now it will look nicer. So now it doesn't do the shadowing thing. The problem here is, let's set this to 15. Now it will actually move quite fast, but it looks like I don't know. It moves 0.3 frames per second or something, but it's actually drawing 60 frames per second. So this is kind of stupid. So how can we make it work smoothly? We have to do something else. So we can't use this in this way to actually do that. We have to kind of calculate where this should be at all points in time. So I think we'll start out by creating a rock, like a business entity. So let's do that. New Java class, and we'll create a rock. And this rock here, we're going to define some variables, an x value, a y value, and you're probably wondering, why am I using doubles? Because you cannot, for example, you cannot put something at 0.5 pixels. But it is actually for calculations. This will give us more precise calculations, and we will round in the end. I'll show you, it will be really smooth. Private image and private double speed, private double direction. This will be in radians, and this is just because this is default. Okay, so the image should be JavaFX image like this. Okay, so what I'm going to do now, I'm going to create getters and setters for everything. So I do this by Alt Insert, or on the Mac it's Control I. Choosing getters and setters, everything, go. And I use Control Space for generating an empty constructor and also a constructor with all of the stuff in it. So this is my rock. So what I want to do instead in my main controller is then, instead of this calculating its position based on time right now, I want actually the rock to calculate its own position based on its current speed and direction. So we need to do some kind of vector calculations, but I'm going to do it really simple here. So I'm going to create a method here called move. And what move will do is just move it based on the speed and direction and x and y value. So I want to update x and y based on its speed and direction. And every time I do move, one time has passed. Okay? So let's look at that. So I will say, so let me just briefly explain here. So I need to first calculate the difference between the x value, and I want to calculate the difference for the y value since the last move, and then I want to say that x equals x plus equals the difference in x, and y plus equals the difference in y, like this. And of course we need to set this. So the difference in x and the difference in y based on the speed and direction. For the x value, we have to use the cosine function, which is in the math. And we have to take the angle, and the angle is the actual direction here. And we have to multiply that by speed. And in the other direction, it's almost the same, except we use the sine function. So I know this is not math class, but let me just briefly explain why this is so. So let's try to look into it. So if we have a speed and direction, let's say we're going this way. So each point in time we go from this point to this point, and the next point in time we go the same distance. So if we know it's the same distance each time, so we calculate the distance, the difference between this point and this point, and we say that this is the speed, right? The speed in that direction. And then we have the x direction here and the y direction here. So the difference between the point here and here in the y direction, we can call this the difference in y. And this one is the difference in the x direction, so we say that is the difference in the x direction. And then we can say that we know the angle, we know the direction it's going, and we know that in radians, so this is d for direction. In our program we call it direction and speed. Here I call it d and s. This d has nothing to do with this d. This is just means the difference on x and difference on y. So we know, we have some idea that we know that the cosine of some angle, if we have the cosine of some angle, it is always if it's the cosine of this angle, it is actually this line here, so the cosine would be the dx divided by s. And for the other side, it would be the opposite here. So that would be the sine of the angle, and we call the angle d in this case, so let's call it d, would be equal to dy over s. And this is actually equivalent, if we multiply by s, this would be equivalent to s multiplied by the sine of the angle d is actually dy, the difference in y from the last point. And if we go into our program, it is speed times the cosine of direction and speed times the sine of direction. So this we can actually use for calculating where we're going if we know the speed and direction. So this is why. So then we add it to the previous value and add it to the previous value, and over time we get in the right speed and direction. This is nice. So let's, now we calculated that, we can go back here and we can say, then instead of doing this, instead of using image rock, we'll actually say we'll create a new rock. So I'll create a rock, new rock, and I would say that it should start at 25 in the x direction, 0 in the y direction. It should use the image of the rock, and the speed of it should be, let's say, 15, and the direction should be something like pi divided by 2. And pi divided by 2 will be the direction going directly down, because we start, the angle 0 is, let me show you. So if we have, this is the angle, let's just draw a circle first. So the angle 0 is here. So in the other side here, this is pi. And going all the way around, this is 2 times pi, and this is pi, so pi divided by 2 will give us the last angle, which is here. So this is pi divided by 2, right? So that's it. Yeah. So that's why it's pi divided. We wanted to go directly down because this is the example I talked about. I had these guys going downwards here. So let's try this here. Let's see. So now instead of doing this, I'll just say rock dot get image, rock dot get x, and not use the time, rock dot get y. And now I'm no longer dependent on relative time and all of this weird stuff here, nano time stuff. Out that goes, and let's see what's going on. Nothing. Okay, so I made some stupid error here. So let's see here. We say rock get image. That looks fine. 25 0 15 math pi get x get y. Ah, okay. Now I see. So I forgot to make time, so I have to do move, otherwise it will never move, of course. I have to move. So now it will move. Nice and smooth, maybe a bit too fast. Let's put it down to 5. So remember, it will be moving 60 times per second. So 5 will also be very fast. So if we put it to 2, should be able to see it working smoothly downwards. Nice. So now that we can drop these rocks, we want to have more of them. So how can we do that? So if I want to create another rock, I could do that and then draw it in here. But I actually want to have a list of rocks because I want to have multiple rocks. So I'm going to create a list of rock here and call it rocks equals new array list, like that. And I just have to import list, and I have to import array list. So now I have my rocks here. I'm going to add the rock I already created, like that. And now I'm going to move all the rocks that I have in here. So I'm going to say for each rock in rocks, rock 1. Oh yeah. So I'm going to say rock1.move, and I'm also going to draw that in here. So not rock, but rock1. And this one clears the screen, so it's probably a bad idea to draw the rock and then clear the screen. Probably should be the other way around, so let's do that. Go. So it still works, right? So let's have multiple rocks. So let's say I create one more rock. let's call this rock 2. And I create that somewhere else. 50, right? Nothing happened. I need to add it to go again. So now I have 2 rocks. So this is kind of tedious. So what I want to do now is I want to create like more rocks. So I think I'm going to create a method that actually creates rocks. So I'm going to do a create method down here. So I'm going to say public void create rock. And this create rock method is just going to create a rock like this. And I'm going to put it directly inside of, so I'm going to say rock like this. And then I'm going to put it directly inside of this list. So I want the list to be a member list like here for now. So I'm going to say rocks.add rock. So now I'm missing the image, so I'm going to take that from here and put it down here, and I'm going to remove these 2 rocks here like that. So now I can create a rock. I'll do that. The problem is I can now do this twice. So this will create 2 rocks, but they will both be created in the same place. So they are just on top of each other. I could put that as a parameter here, but instead I'm going to create this randomly. So I'm going to create a random generator. I can use that. I just write random. And now I have a random generator, and I want to use that as the input for my creation of the rock. So I do random here. And now I can set this random next int, and I can set a value from 0 to, oh, I can't have the canvas here. So let's just say for now put that value 960. This is the canvas size, right? New rock, blah blah blah. So let's see what happens. So now it's somewhere else, and if I start the program again, it will be somewhere new. So that also means that now I can create multiple rocks like this, and then they will spawn in different places. At the same time though, so what I want now, I want to put this in a loop, of course. So I'll just create a for loop, and now I can create 10 of these like that and make them move. Okay. Yeah, so that's it. Now I can create multiple rocks. So the next thing I want to do is that I want them to be created at certain time intervals. So what I could do, I could put them inside of this, and this would create 60 rocks per second, which would look kind of wild. Okay. So now I'm spawning these 60 rocks per second. And I could do some kind of limitation on that, but this is how it works right now. Okay. So now it's raining rocks, and now I think I'm also ready to show the problem with this game here. So let's say that you have a game, and it doesn't need to be rocks like this. It can just be that you are creating a game which are spawning something like it can be enemies or whatever. You're fighting them, they go off screen. You fight someone else, they go off screen. And if you're not deleting them, if you're not deleting references to them and creating them all the time, it's kind of expensive. So let's try to look here. Now I open my task list here, and we can see here this is our program running, and we can see that it uses approximately 200 megabytes of memory, and it's rising slowly. And that is because that when these get out of screen, we also see the CPU, it's kind of rising slowly, goes down and up, but it is rising over time. So the more we create of these, the more is calculated. So the array list behind this is just getting bigger and bigger. So we see now it's 25%. So it's getting bigger and bigger, and it needs to calculate the X and Y values for all of these all the time. And right now, I don't know, we probably have like, I don't know, 100,000 or something like that. I have no idea. But we see it getting bigger and bigger doing all these mathematical calculations. So this will take some time to reach 100% here. So it uses a lot of power, and at some point we'll also run out of memory. You can see now it's 100 megabytes larger than when I started to talk about it. So let's try to stop it and make it run out of memory faster. Right now these images are very small, so we're going to make them bigger. So we could set the size of the images. So actually where we create the image right here, we can set this to 500 instead. That will use up a lot more memory. But now things will be fun. So let's run it. And then look at the task list here. And now it uses up 500 megabytes, 100 more, and when it reaches about 1 gigabyte, it totally... So there's probably some cap here with the Java virtual machine that it cannot use more memory than that. And then it tries to free up some memory with garbage collection or something like that. Goes down a bit. But it's not really working as intended. It even uses up a lot of processing power and even some GPU actually. 92%. Wow. So it's really not working out very well. Did you see how fast that went down? Let's just try again. So of course the more expensive the objects you have, the faster it will fail. So it really grows fast, right? 100 megabytes on like 5 or 10 seconds. It's really fast. Now it died already. So this is not very good. So the problem here is that I just keep creating the objects and I'm not deleting the references. So also we lose a lot of CPU power calculating and recreating all of these things. So what we need to do is we need to use the actual object pool to actually solve this problem. So this was the simple game. So in the next video I'll try to apply this pattern here. I'll try to apply this by creating a pool of objects that we use instead of just creating the objects by themselves. I'm going to implement a small queue that will actually save all of the objects that are out of screen so we can reuse them on screen again. So that is for the third video, this is what I'm going to do. Thanks for watching.